everyone. My name is Vova, and today we're going to talk about data and how we use data in developing new services Uklon, and how we use data for optimizing existing services and products. Let me introduce myself briefly and a few words about my background. I'm with Uklon more than 2 years. I'm head of data science and analytics team in Uklon, and all requests that are associated with data science reporting and data sources is what I'm taking care of. Let me introduce Uklon company briefly. We are Ukraine, one of the Ukraine leaders in ride-sharing market. We are 11 years on the market, and we have more than 10 million downloads of our apps. The main goal of our company is to design transportation services which help people to make comfortable rides in the most affordable way. Talks about data could be different, but today I want to show you one example how we use data for developing our matchmaking system. Uklon provided the new product. It's called UklonShare. It allows you to share the cost of your ride with the companion. In this report, we will talk about how we use data for developing this system and which data we used before we started to do it. So I want to divide my report in 3 main areas. Firstly, we will discuss what are the facts and how we decided to do this product. Then we will go through the chain of our algorithm hypothesis, and finally we will see what we gained and what are the next steps. So let's see the facts. In March 2020, COVID lockdown was launched in Ukraine, and at the same time we saw how the percentage of shared trips start rising. The rise was gradual, so we wanted to know what happened. All you know that all of types public transport was unavailable. It was only available for emergency workers. Also, we saw that people started to self-organize in their trips. They combined the different trips in one general trip, trying to reduce their cost of the ride. According to this fact, our product team developed the general customer research. The main goal of this customer research was to find out how people react to so-called inconvenience. For example, if ATA of your trip rise more than twice, or if the length of your trip rise more than 1.5, or for example, if you have to walk 5 minutes to reach your pickup destination. The result of this research was surprising for us. We discovered that any inconvenience which is associated with time, distance, or availability of a service is covered with the amount of the discount. So we know that people already do this, and what we are going to find out, how do they? We find out that there is a huge variety of chats where people trying to find a companion. Also, we found chats where the drivers were proposing their rides. So what is the main problem? Fact number one, we know that our US competitors that already use sharing economy in their yearly reports showing the rapid growth of percentage of sharing rides. Fact number two, we know that the market in Ukraine is small but stable, and it remains only to provide the convenient tool which for lowering the entrance threshold. So with these facts, we started to develop our product. We ran a simulation on Kyiv trips in March 2020, and we realized that 70% of our trips has the significant portion of overlapping roads that could be shared with the other trips. It only remains for us to. There was a funny fact, because we are not the only one player in the Kyiv market, but yet potential majority of these rides are still was able to match with other rides. So with this information, we started to develop the first iteration of our algorithm. It's called version 0. And the first requirements was we wanted to start with scheduled trip, because in such way people do these trips in their Telegram channels. And also we started to calculate distance between people with map, not using roads. Also we limited the number of our users for 2 people because of the limit of calculation between roads. We decided to use greedy algorithm. Who knows? It just does brute force, which you take only one ride and trying to find the difference to other ride. So the first iteration was done, and what are the downsides? The fast customer development showed us that nobody wants to make scheduled trip, because we translated this product to our existing users, and all of these users wanted to request their trip in the same time, even if it was needed to wait 10 or 15 minutes. The second downside was that we compared every passenger with another passenger, and it takes a lot of time to make calculations. That's why also this greedy algorithm showed us that it made the optimal minimum of each ride, but it's not good situation for our unit economy of our system. With this information, what we could do with this information, yes, we started to optimize our first version of algorithm. The next stage of the algorithm, it was called version 1. There were new requirements. We added real-time requests to make our user happier. We started to calculate unit economy. What does it mean? It shows us the maximum count of rides, not only the best match for each ride. For this, we implemented the nearest neighbors algorithm, and also we started to use Hungarian algorithm to find the best way for our system. The main thing we implemented in this version, it was the new efficiency coefficient. I'll show it in details. As you can see on the illustration, effectiveness indicator is used to see the difference between the road overlap of 2 users and the total sum of distances for this user. This effectiveness indicator showed us what is the best way to find the best match and the best way to have unit economy with a plus. Here you can see an example when effectiveness indicator is 5%. Points 1 and 2, it's pickup points for 2 riders, and points 3 and 4, it's drop-off points for these 2 riders. When we match this trip, you see that user from point 2 to point 3 shares only the half of the way of the first user. It's not good for economy, and we have to subsidize this order. Here is another example when effectiveness is 33%. As you can notice, the maximum value of this indicator is 50%. In this case, you can see that the significant part of the road is shared between two riders. So, with this information, this effectiveness indicator, we started to make our last iteration of version 1 algorithm. This solution helped us to rapidly grow our match rate and helped us to make count of our the value of our orders much more bigger. But also this iteration showed us some new downsides. It was an insufficient match rate. We had a lot of, after the version 0, we had a lot of orders, but they were allocated between all of the city in all city zones and between all of the buckets of the hours. Also, this allows people to, they didn't understand what happened and they started to cancel their rides. And we noticed that the cancel time of these rides were under 60 seconds. The one more significant downside is that we undefined time from P1 pickup to P2 pickup. It was not obvious for user in our UX on the app. So, with these things, we've gone to the version 2 algorithm, and the main requirements of this thing was to make match rate more than 60%. The other thing we wanted to reach was match waiting time. It was under 60 seconds. We made a lot of efforts. This is an example of one of these. You can see here how we divide our efficiency rate in the horizontal axis and how we divide hours in the vertical axis. We were trying to find the best match group where the match rate is the highest. Also, we tried to understand how these orders allocated in the city between city sectors, and we started to divide our Kyiv orders to the different parts of cells. As a result, we have such table which shows us where the match rate is the best, and this solution helped us to build such kind of map. And after the map was done, we started to make different hypotheses. What can we try on our product? As you can see, we got a detailed map with specific time buckets where the probability of match is the highest. This solution helped us to make match rate more than 75%, and it raises the count of successful trips in our product. So, what was the last version of our algorithm? We started to use certain sectors to limit the requesting of our product in the city. Also, we use the schedule of time to increase chances of the highest match. All of this were turned after after tens of iteration, and the last thing we started to use here was the compensation. As we know, it's the most cheapest way to show our new users how to use the product. And also the compensation works when you are waiting for your companion and more than 10 minutes. So, what we learned and what we got as a result. Our match rate now is more than 75%. Average cancel time in our product is nearly 60 seconds, so our users wait for the companion because they know that the match rate is high. For this time, our best result was 20,000 MAU, and for all this time the product works. We had 70,000 of successful unique riders. See the flow of our product, how it works now at this moment. At this moment, it's available only in Kyiv, but we are working on in sites to find other cities in Ukraine to try it. So, what's next and what are the next point for us? We want to try triple matching, but of course we're going to try it after the COVID limitations is over. Also, we want to improve our passenger experience because we know a lot of problems after our customer developments which user faced. For example, we can show them at which side of the car you can sit, or how many time it lasts your trip to find your companion. But the main bet for this product is to find the new cohort of our drivers, because the problem is we use to ride our shared trips, we use the local drivers, and we have a guaranteed minimum tariffs. That's why we want to find the new cohort of our drivers that can apply the lower tariff, and in this way we can reduce the cost of our trips. So these three challenges are require a lot of effort, and in case if you have any ideas or know how to optimize our product in future, you can join our team just using this QR code. You can see what available positions at this moment are. Also, if you have any questions or discussions, you can shoot me a message in social networks, or we can discuss it now just after this final part. Thanks for your attention.
What's the main problem to share the algorithm to another cities like Lviv, Kharkiv?
Actually, our algorithm is very sensitive of density of the orders. So you have to, for big probability of match rate, you have to have a high density of the orders in the city.
When I'm calling for taxi, I can get up to 4 passengers, for example. If I'm call and get this shared driver, I can go only for myself without, or with my girlfriend, for example.
Okay, yeah, we allow +1 passenger with you.
And what about if both will be +1, it will be one at the front, and it's not COVID safe?
Yes, we changed this limitation, depends on the COVID lockdowns. At this moment, when lockdown is not over, you cannot take +1.
It's related to the first question. So, does it mean that you have some issues with reusing the same like model from Kyiv in Lviv like area with same like way of using? We use same roads, same like users. So why we cannot reuse it? And another thing, when user is trying to like order some car, do you have an option to propose him while he is waiting to? Oh, do you like to like share this car with someone else?
Yes, so the first question, the algorithm is working, so we can just use it in the other city, but as I mentioned before, it is very sensitive of density of the order. So we should firstly allow us to have more orders in the city, and then we can try this thing. And I didn't understand your second question. Please, can you rephrase?
So when user is like ordering some car, right? So like for example, I need to pay 70 hryvnias to get to some place, right? And like while I'm waiting, probably I'd like to see some notification, or you can share that price with someone else who is also trying to drive to like similar direction. Do you have something like that?
Actually, this is like new another business model. In our country, Uber chains use this business model, but we made a separate product which allows you to order only share.
Hello. What was the time frame between the launch of the algorithm V0, V1, and V2?
I think we're working on this algorithm, the chain of hypotheses, more than 1 year, starting from March 2020. But the first and the second iteration, it was, I think, 2 months between them.
Okay. And what was the timing between the idea and the launch of V0?
Oh, I think it was maybe 2 or 3 months.
Okay. Thank you so much.
The topic of this meeting is like using the data to discover new products. But as I know, in general, Uklon has a lot of products, but related to taxi drivers. Are you going to create something new? Because you have really big data, big experience, and for example, Uber across the world using this data to create a lot of different services. What are you going to do in Ukraine with it?
Actually, we had 2 more specific ways to develop our business. But, for example, what can you do with data just from your user trips?
In general, you have a lot of different data. For example, if you're talking about Facebook, for example, they use this data for each they're selling it, they're using by themselves and so on. Are you selling data? Are you some?
Okay, I understand. Actually, not. We do not sell our data, but we are interested in buying data from other third-party sources. For example, we started our own project of traffic jams, and this project is at this moment based on our own data. But we are going to buy data from other sources to make it to save it in our engine. So it's a kind of mixed data from different sources, and we are going to find new insights in it. Do you have more questions?
Do you have knowledge about problems that drivers work on different platforms like Anabols and Uklon at the same time, and sometimes they accept the ride from the another one, just riding, he is driving at this moment, and you just have to wait more. And sometimes users don't want to share feedback and just don't share. How will you just analyze this data? How would you handle this case?
Actually, thanks for your input. Actually, I don't think it's connected to this term, but answering your question, we have a very strong feedback management. So you can just make a feedback of your trip and say all of what you think. We will see it later and take care of it.
But sometimes users don't want to share it. Just okay.
One of our goals is to make higher penetration of feedbacks to our trips, and actually we are working on it at this moment. It's like we are going to motivate you to share feedbacks. Okay.
What technologies do you use to build the product framework algorithms?
This algorithms is built on by our data science team. We use Python to write code, and we have our own MLOps environment to make it to launch it in prod.
Own data center. Like,
Yeah, not own. We use the different providers, but I mean we have our own environment.
thanks.
Okay.
I have one more question. So when you showed the heat map of efficient journeys, usually they were on the outskirts of the city or on the Libya. So it means that these are commuters during the rush hour. Do you have a problem that these people who often travel together, they find companions and the taxi driver, they negotiate the trip with the taxi driver without using Uklon as a middleman? If this happens too often, like for the job or a regular commute. So do you have this problem, and if yes, how do you deal with that?
I understand. Actually, I think this problem is not only for UklonShare. You could do it even if you make regular rides every day just using our standard products. But in this case, when you don't use Uklon application, you don't use our features like an insurance and the same like feedbacks, so you can't influence on your rides in future. That's why you are motivated to use Uklon, because often driver don't want to give you the same discount as he don't pay us without the app.
Yeah. Thank you so much.
Okay.
Does Uklon works in other countries?
Uklon? Not yet, but you have to read news more often about Uklon now.
Yeah.
We are going to launch, yes.
Thanks.
In matchmaking product, how do you decide on the price? Is this like split between the two passengers, or is there some algorithm behind that?
Actually, not. We don't split it between passengers because, as you see on this map, the match is always different, and we had efficiency rate, efficiency indicator. Here it is. So in this case, you see that we can't split it on a half because we have these rights. But the rule of the condition of UklonShare is you have a 40% discount in case you find your companion.
Okay, thanks.
Okay.
One small question. So is it possible to use different ways of pay for the trip, like with your card?
You mean cash and with card? Yes, it was one of the features we launched later.
Yeah, but I mean, like, is it possible that one guy will pay with a card and second one with cash?
Yes, yes, mixed pay. Okay.
How often do you make new releases of the application algorithm?
You mean matchmaking algorithm or other?
From like CI/CD standpoint, when you have new idea, like develop code, and how much time do you need to make new release to the code production?
To be truth, it depends on new product features. So, if needed, we can do it even each sprint, even 2 weeks. But at this moment, last release of Share, I think, was 2 months ago, or even more.
Do you use it?
Yes.
I have never used it, and it's interesting now to try.
Do you live in Kyiv? Yes, you can try it. You can find locations and time buckets of availability of the service and try to use it in Kyiv. And try to recommend your friends to use it after this report. Okay, guys, we have a present for the guys. And I'll share this backpack for the best question for you.
Дякую.
And one more thing, we are going for other two questions for this guy from Kiev who are going to try share. And this guy.
Okay.
Okay, and the last thing we have the best present for participant here. Darina, can you please show the list of potential winners? Come here. Come here. This is your prize for the participation.
Oh, thank you.
I can stand here. Thank you. So thank you guys. See you.
Thanks.